For the first half of our summer here in the Pacific Northwest, I've gotten a lot of reports of this pesky little wind that has been occurring that doesn't seem to be normal. Well, that's because it's our good old friend, the sea breeze. In the second half of the summer so far, at least, we haven't really seen this sea breeze. This video will be explaining why both are perfectly normal. So we'll start with what is a sea breeze. Sea breezes form when the temperature in the ocean is significantly cooler than the temperatures on land. You need little external influences for this to form. What I mean by that is if you have a offshore flow pattern, that will normally overpower any sort of sea breeze from forming. And this is because a sea breeze is pressure driven. Now, cooler air tends to be denser than hotter air. As a result, when the land heats up and land heats up far more quickly than the ocean, that lowers the air pressure over the land temporarily during the hottest part of the day. This is why sea breezes tend to happen during the afternoon and evening hours. Most commonly, I've known this from about 4 to 11 in the evening, though I have seen this start earlier in more extreme situations or on the coast. And as that warm air rises, it starts to go back out to the coast because generally speaking, there is a upper level ridge that is nearby, which helps influence the land areas being hotter. And then once you get back over the ocean, that pressure up aloft is lower, which then sinks back to the higher pressure of the ocean floor, and then the cycle repeats itself. There's also an opposite phenomenon called the land breeze, which can happen, but it's not as noticeable because most of us tend to be sleeping when that happens. Winds typically are 10 to 25 miles per hour. I have seen extreme situations getting up to about 40 miles per hour. And then also, as a side note, this can lower the temperature by up to about 10 to 15 degrees pretty quickly. More commonly, it is right in that 5 to 10 degree range here in the Willamette Valley, and there's a few locations that experience this more than others. So, most sea breezes go through gaps in the Coast Range, with Corvallis and Sheridan being in the brunt of this in Oregon. Longview can experience this in Washington as well, but they don't get as big of a wind tunnel effect. So, generally speaking, and these lines are going to be approximate here. So, the Yakina River goes pretty much right along Highway 20 and Highway 180 here before transitioning over to the Marys River Basin, which creates one of the shortest passes in the Coast Range. And up north, around Highway 18, you have the Salmon River, which pretty much parallels Highway 18 for a while before diving inland a little bit past Rose Lodge, before looping up with the Yamhill River, which follows Highway 22 and Highway 18. The passes over the Coast Range here are only about 700 feet compared to up north, where Highway 26 and Highway 6 both go above 1,500 feet. Because cold air is denser, it makes it easier for it to cross the Coast Range here. And because this is narrower than the lower Columbia River Basin up between Longview and Astoria, that enhances the wind tunnel effect as well. So there are situations where Corvallis, Sheridan, sometimes it can leak over to McMinnville, can get a sea breeze, but the rest of the valley is pretty calm. In more extreme situations, which we have seen this summer, the entire valley sees the sea breeze, but it's just these areas see it first instead and have the highest wind from the sea breeze due to the wind tunnel effect. It's also why I say occasionally that if you're in a heat wave without a lot of wind, Corvallis is one of the best places to be in the valley for that. I do want to note the difference to onshore flow because by the technical definition, a sea breeze is onshore flow. So onshore flow can happen most days. Sea breezes are limited to our driest days with very little wind to start. So that pretty much just eliminates everything to just our heat waves. Versus onshore flow, we can get that with our winter or rainstorms, snowstorms, high pressure systems. We can even and get them, like our most recent heat wave in early August. So onshore flow is just far more versatile, but it includes sea breeze as part of the definition, but it's just a subset. And then sea breeze season, this is the last thing I want to touch on this. Typically, it's from April through July. The reason for this is, like I mentioned earlier, you need a cooler ocean. The sea surface temperatures off our coast peak in September, while the hottest time in the Pacific Northwest is usually late July and early August. So this is a sea surface temperature graph, the daily values in the Eastern Atlantic. I could not find daily values for the Eastern Pacific that flow in a chart like this. The Eastern Atlantic has a cold water current just like the Eastern Pacific, so I thought this was the closest comparison. And plus, based on sea surface temperature patterns, the entire northern hemisphere follows a similar pattern. So, the minimum sea surface temperatures tend to be in February and March before rising up starting in April and then really accelerating in June and July. So, if we can get the proper pattern in April, May, June, and July. Great recipe for sea breezes. Earlier on in the season, we do tend to get more or offshore flow heat waves, so we haven't noticed as much in April and May as we do in June and July when that offshore gradient dies off until it comes back for our late summer heat waves. And then once the sea surface temperatures warm up, off our coast, they could get to around the low to mid 50s typically on average, though they are a little bit above average as of August 2025. That pretty much kills sea breeze season because, well, it's warmed up 4 degrees since June Fahrenheit, 2 degrees Celsius. So the last thing I want to touch on, and I didn't include this in text versions here, is humidity. This can indirectly increase the dew point because you are flipping to a breeze coming from the ocean, which contains moisture. But the dew point will never in this pattern reach to the levels of the Midwest or Southeast. Dew points will probably be in the 50s to low 60s in a sea breeze setup, depending on where we are at in the season and how hot the temperatures are in the valleys that are triggering the sea breezes. Hotter the temperatures is in, let's use July for example, if it's 95 and a sea breeze triggers, you're probably going to get dew points right around 55 to 62-ish degrees, for example. So that is going to be it for this video. I am recording this a few days before another heat wave happens for the Willamette Valley, so videos are being activated at the same time as this. Unfortunately, this time it is not a sea breeze setup because we are in late August. So sorry to disappoint you with that. Otherwise, stay safe out there and take care.